Okay, now first of all with these ones, because I'm using these operations again, it pays to actually create them as a matrix. I've got A as matrix A with the elements 7, 3, 5, 9. Given the fact that I have to use that 3 times, we need to go to our calculator and we might as well go ahead and store it, shall we? So let's go and do that. 7, 3, 5, and 9. And let's go and store that. So we go control variable, which stores it. Oops. Make sure you're outside of that. Control variable, and we'll store that as A. You've got to press A to begin with, don't you? All right, let's store that as a variable A. Likewise, we've got another variable B that we'll be using, 6, 2, 10, and 4. So let's go ahead and do that, and we'll store that as B. It's quite small, icons. 6, 2, that was 4, and that was 10. And I'm going to store that as variable B. Press enter. And now what we want is we want A plus B, A minus B, and A plus B times A minus B. Okay. So let's do that. Now you'll know if your variables are stored because you'll see that bold, in bold. So we want A plus B. And that's going to give you this matrix here. A minus B. And give you this matrix here. And those we could multiply those two together if you like. You can do that if you want. By the way, you can go up and you can press enter. And then you can do multiply and you can go up and press enter. We could have done that, or we could have entered it again. And that's your answer. Is that making sense so far?
Yep.
How many of you stored the matrices as variables? How many of you actually stored them as variables? There's a few people I know, but I think maybe some of you could have done that and saved yourself a little bit of time. Okay, the next one. What was if I wanted to find the determinant, not by hand though, what was the function we could use? What was the function we could use? Well, the function is det for determinant. And we could use that function in our calculator. I'm not sure if you guys remember. I did show you it. And what was the matrix? What was the elements? What did we have? We had negative 7, 4. Negative 7, 4. 38 and negative 22. Now you could do that if you like. And you can work out that the determinant is 2. But all we are doing to find the determinant, I'm going to do it by hand. We're going to say that that's AD minus BC. And so I'm multiplying these elements here. Negative 7 times negative 22 minus BC, which is 4 times 38. This is going to give me 154. Minus 152 is equal to 2. Determine whether determinant B is equal to determinant A. Well, determinant B is equal to det of B is equal to 70 minus 72, which is equal to negative 2. Therefore, det B does not equal det of A. Awesome. Okay, now let's find the inverse. Remember, the first step for the inverse is we need to find the determinant. Determine if it's non-zero. So we ask ourselves, is the determinant A 0? No, it's not. So an inverse exists. We know that. So what do we need to do? Well, I guess we're going to do a bit of a... going to do it fairly quick because we've done it a fair few times. We're going to swap elements A and D over. So negative 22 becomes A now. Element D becomes negative 7. And we're not swapping elements B and C over. We're not swapping these two over. We're just taking the sign and changing it. So we've got negative 4, negative 38. And we're dividing through by the determinant. Now, dividing through by 2 is like a scalar multiple of 1/2. Now, of course, you can go ahead and put that through, and therefore you can then simplify fractions. 22 over 2, though, is 11. So we've got negative 11. Negative 4 over 2 is negative 2. Negative 19. And negative 7 over 2 we could just leave as a fraction. And that's the inverse, finding it by hand. Remember, we want you to be able to find the inverse by hand. You do need to know how to do that. And some multiplication. Multiplying matrix A times matrix B, that's a straight calculator one. What's the answer? What did we get? Negative 13, negative 16, 68, 84. Okay. Now, importantly though, we've got AB over here. AB, you must remember, is not necessarily BA. Rarely is it. If I'm multiplying two matrices together, order matters. Now, if I was to go ahead and find the inverse of A times the inverse of B, then the inverse of A, inverse of B, straight calculator question, which we will do. What is A? A is negative 7, 4. So the thing about matrices is that a lot of the time you are using your calculator and you can get a lot of easy marks due to that fact if you know how to use your calculator. The problem is when it comes to solving or applying that knowledge, then if you don't know what you're doing in terms of using inverse matrices to solve equations and setting up matrices, then you're going to have some problems. So that's to the power of negative 1, and I'm just going to, because we only have to use it once, I'm going to multiply that by another 2 by 2 matrix, and that is 7, 8, 9, 10. Oops, 7, 8, 9, 9, 10, and we want that to be the inverse, so it's to the power of negative 1, and you should have got that. You might have it in decimal form as well, but fractions is fine. Let's say we want exact values. We don't want big decimals. Okay, so far so good, hopefully. This one, I'm not going to do this one because you guys can just do this straight in your calculator. We're just putting this matrix in here, we're squaring it, we're squaring this matrix here, and we're subtracting c squared away from it. You can't do it by hand. Has to be a calculator, straight calculator question. And the same thing, you can store them as variables and redo it there. I'm not going to go through that, but you guys can, I'll trust that you know how to use your calculators. Extended response question. Can two matrices be multiplied? Well, we need to look at the order of the matrix. My matrix A is a 2 by 2. Matrix B is a 1 by 3. I've got my two trains. They're not connecting because of the column in this train is not the row of this train. So therefore, we have to ask ourselves, no, it's not possible. But why? Because the rows for one the columns for matrix A does not equal the rows from matrix A, for matrix B, sorry. CD, 2 times 1 by 1 by 2. Yes, it can. These are the same, so yes, it can. B and E, 1 by 3 by a 3 by 1. Yes, it can. These are the same. We are absolutely happy, aren't we? We are so happy. Okay. Moving on. Now this one, I like this question. A 2 by 2 matrix whose elements has fallen out. We've got a determinant of negative 86. What does that mean? It means that A times D minus B times C is equal to negative 86. But they're telling us of this matrix that the element 2, 1, which is row 2, column 1, is 4. And I've got 3 numbers. Negative 6, 5, and 11. Now, as it turns out, if you wanted to play around with this, you could say, well, if I put a 5 here and an 11 here, 11 times 5 is 55. That means that this would have to be negative 6. 55 minus 24, not going to give us our result. So we know that 5 and 11 is not going to go here. So 6 is definitely not in that element. 6 is going to be somewhere in here. So we play around with it a little bit, and I'm just going to put negative 6 there, and I'm going to then say, all right, let's put 11 there, and let's try 5 there. Let's see if that works. The determinant of matrix A is equal to minus 6 times 11, subtract 5 times 4, which is equal to negative 66 minus 20. Look at that, it equals negative 86. Now, I could ask you, are there any more other outcomes? Yes, there is. We could swap elements A and D. I could do that now, and I'm still going to get the same result. So there are 2 possible answers. As long as you provided one of those, we would give you the mark. Okay, so if you wanted to do it like so, then that is also well and truly okay. Are there any questions about that one? Now I'm getting a cold. Okay, this is where we really need to work through it, because I know a number of students don't do that. We're just going to do part 1. Okay, you guys can do part 2 yourself. Rewrite or write each matrix, write each in a matrix form. Now, first of all, we need to realise that if I've got my set of linear equations, 2x minus 3y, we're looking at the coefficients. Okay, so the coefficients is that number out the front, 2, 3, 4, and be careful, some people wrote 0. There's actually a 1 there, isn't there? So my matrix is 2, negative 3, 4 and 1, and if I was to multiply that by, and this is where knowing matrix multiplication really helps, because let's have a look at this. If I was to have x and y, which is my 2 variables, if we go ahead and we go and do some multiplication, we go across and down. So let's have a look. 2 times x, and then we go across minus 3 times y. So 2 times x plus minus 3 times y is equal to 3, which means that on the left-hand side of your the right-hand side of your equation, we actually have to have equal to 3. Same thing, 4x plus y is equal to 5. So it does help to know how matrices multiply, because you'll get some questions which directly sort of require that knowledge. Solve to find the solutions. Now we've got to find x, y. Now the whole point of us doing inverse matrices is because the inverse, we need the inverse to effectively cancel out this. And if we cancel that out, because we use the inverse operation, then what that's going to do is we're going to be left with x, y. So let's have a look, and this is where we say we've got that matrix A inverse times matrix C is equal to matrix B. That's the rule that we've got. That's the rule that we've got in our notes, and that's where that comes from. Okay, so you've got to understand that rule. That's so important. If you don't understand that rule and where it comes from, you need to revise that prior to your assessment. Now, let's go ahead and do it then. So what we're doing it the long way. If I do the inverse of this matrix A, which is this one, which was this matrix here, then we're going to have that, and we're going to put that in your calculator. So what we're going to say is the inverse of that. I'm multiplying both sides by the inverse. So let me just show you what that does. Okay, you sort of just take it for granted and rote learn. But that's essentially what we've got. Now, if I've multiplied the left-hand side by the inverse, I have to do the same to the right-hand side. So if I do that for 1, negative 1, 3, 5. Now, if we look back in our rule, this is matrix A, this is matrix B, and this over here was matrix C. So what we're saying is if we want to isolate this xy over here, then that is equal to the inverse matrix A times matrix C. This thing here. Okay? So what we're doing is this inverse is going to cancel out this function here. Why? Because the inverse matrix times a matrix gives you the identity matrix. In this case, it's going to be 1, 1 because it's a 2 by 2. It's a square matrix, and we did look over that. That essentially is like multiplying it through by 1, cancelling it out. So the answer is this matrix multiplication of x and y, which what did you get in the end for that one? Now you're going to get an answer. You're going to get, when you do this in your calculator, you're going to have xy is equal to 9 over 7 and negative of 7. That was for one element, and negative 1/7. So therefore, you haven't answered the question though. X is equal to 9 over 7, y is equal to negative 1 over 7. Yes?
When we work it out, do we have to show like the inverse of like, can we just show straight to the inverse, or do we have to show
What I'd like you to do is write out the equation, what you're doing in the calculator, and then write your answer. Okay? So what the thing is a lot of the time with this, we're not asking you to find the inverse by hand. But what we are asking you to do is to show a method mark. In other words, write out what you're doing in the calculator. Okay, so if you do that, we're perfectly fine. Okay, now it says down here, find matrix X in each case below. I'm not going to do all of them, but I'm just going to do this one here. What we're saying is, if I've got Wx is equal to V, how do I find matrix X? Well, what I've got to do to find matrix X, then I've actually got to cancel out matrix W. So what am I multiplying the left-hand side by? Andrew? Yep. How do I cancel matrix W? Times it by? The inverse. That's what you said, didn't you? Yes, okay, great. All right. Multiplying the left-hand side, multiplying the right-hand side. Now, this is going to cancel that out, and we're left with matrix X is equal to inverse W times V. So, let's do that. So you need to be able to know that matrix X is that times that. You then go ahead and do that in your calculator, which you would have all done. And what was the answer? What's the answer? What's the first element? What did you get, Hannah? Okay, thank you. 11 over 8. 11 over 8. Negative 1/8. Negative 5 over 12. And negative 1 over 12. Okay. And let's have a look at the last... let me just pause this for a second.
Next group of students.
All right, so we're now going to look at this last question. This is the stuff that you need to revise. We need to set up a pair of equations. First of all, let's think about it logically. We've got English books and we've got maths books. So let's just write down what we've got for starters. Now, it may seem tedious, but let's write out what we've got. We've got English books and we've got math books. And English books cost 3 English books and 4 maths books cost $78. So we could say, let's just write 3 English plus 4 math equals 78. We could write out an equation if you like. Whilst 2 English books and 3 maths books cost 56. Well, look at that. We've got 2 equations there. And we can actually, without even really knowing how to set up the matrices, we've already effectively done it by just writing it out like that. Now, what we need to do now is the coefficients of each of these. We can set up an equation. Rather than x and y, though, we've got to find e and m, if you like. So, the coefficients are 3, 4, 2, and 3. And I'm multiplying that by, we won't use x and y, we'll use e and m. And that should be equal to 78 and 56. Now, of course, we need to solve for e and m. Now, this is where you've got to remember your rule, because your rule is that if I'm finding matrix B, then that is equal to the inverse of matrix A times C. Let's have a look. This is matrix A, this is matrix B, and this is matrix C. So, just repetition is the mother of skill. You just need to do this a fair few times. Let's have a look and go through and do it. So therefore, in other words, if I do the inverse of this matrix, the inverse of matrix A, that's going to cancel out the left-hand side. And whatever I do to the left-hand side, I've got to do to the right-hand side. So I'm then multiplying that by matrix C is equal to EM, if you like, which is matrix B. So now I'll do that in my calculator, though. We're not asking you to do it by hand. We may ask you to do it by hand, and when we do, you need to show us the working, finding inverses and things. But the inverse of 3, 4, 2, 3 times matrix C, which is 78, 56, and that's going to give us our answers for English and math. Yes, to the negative 1, sorry. The inverse of that. So I go ahead and I find that inverse, 3, 4, 2, 3. And so 3, 4, 2, 3. And we want the inverse of that to the power of negative 1. And we're multiplying that by matrix C, which was, what was it, 78 and 56? Yep. So we're multiplying that by a matrix which is a 2 by 1, 74? 78. Sorry, my bad. I'm just having a bad day. 50 and 56. And look at that. It's going to give you a matrix, a 2 by 1, which is 10 by 12, and each of those elements are what we're after. So therefore that is equal to 1012. We're not done yet though. State the answer. It's saying find the cost of an English book and the cost of a maths book. Write out in words, please. The cost of an English book is equal to $10, and you can do the rest. The cost of a maths book is equal to $12. Are there any questions about that? It's actually fairly straightforward. It's really just repeating those skills that you've learned over and over again, but applying them. And that's where some students really struggle with it. So make sure that you do practice that. I'm going to stop this video now, and I'll go through the last question, but I won't do it in the video. So there we go.